Welcome to Biology My Passion. I am Soumya Harikrishna. We are starting a new chapter in Class 9 Chemistry, Structure of the Atom. Henceforth, what we are going to study is actually the basis of chemistry. As long as you learn chemistry in your life, you should have this base. Whether you are class 10 or so, anyway, till class 10 you have to study, no other choice. But after that, whether you take up or not, in 11th and 12th you will go far more than this, but base is this. If you don't know this, the whole life you will struggle with chemistry. But if your bases are thorough, you will love chemistry. Okay, so these things you should take time and understand. And one more thing, whenever you are watching an educational video like this classes I am taking, don't see it like animations and all, it's fine, but classes like mine, you don't sit and watch like a reel that you are watching. You have to take your NCERT textbook and a paper with you. Take down the points, pause it, take down the points, and because main points I always write on the board. I don't have time to give the notes, so you have to take down from the points from the notes, or you underline in the NCERT, understand and then learn. It's not that simply you're watching, you forget. Nobody can complete, but you will understand maybe, but you will not be able to learn like that. Okay, so always keep a pen, paper, sit straight and just learning as if you're sitting in an online class. You have to listen to that class. Understood? So now let's see the structure of a certain atoms. So first is a hydrogen. Hydrogen has only one electron. So this is the atom. Around the atom there is the first orbit K. So in that one electron is there. So hydrogen has only one electron, that is in the K shell. Next is a helium. Helium also has atom and the K shell. K shell can have 2 electrons because helium has got 2 electrons. But here the 2 electrons are occupying the K shell, but K shell can have how many? Only 2. So maximum is filled. Now the third is lithium. Lithium has 3 electrons. So 1 and 2 came in the K shell. Now K shell cannot hold more. K shell will tell, sorry, I am full, you go to the next level. So the next level who is there? L shell is there, right? This is K, this is L. So the next one electron will shift here to the L shell. Then lithium, next is beryllium. Beryllium has 4 electrons. So 2 will occupy K. K will not let them in. So they will go to the next one. Sorry, 4 are there. So total 4. Boron has 5. So first 2 gone. Now 3 more are there. They will be sent to the L shell. Now I am going to draw in the same because it keeps on adding. When carbon comes, it is 6. So 2 gone. Another 4 should be here. Then nitrogen 5, oxygen 6, 7, 8. So up to 8 only neon. 10 electrons are there for neon. With that, the K shell is already filled. Now L shell seats are over, seats full, house full. Okay, now next is sodium. So when the sodium has 11 electrons, first 2 will go to K shell is full. Another 8 can occupy the next L shell. Okay, but still one more is left. So that will be sent to the next level, M shell. So it will happily sit here in the M shell. So this is sodium with the 11 electrons. Now magnesium with the 12 electrons, M shell will take. Aluminium with the 13, M shell will take 14, 15, 16, 17, 18. So 18 is argon which has 18 electrons. So 1, 2, 2 plus 8, 10, 10 plus 8, 18 full. Now comes our potassium, 19. So the potassium will take the next N shell, 1 electron will go there. So potassium has 19. So 2, 8, 8 and 1. Then who is there? Calcium. Calcium has 20. So 2, 8, 8 and 2. So all happy. Up to calcium, 20 you have to by heart. In your NCERT, it's given up to argon, but it's better to know till calcium up to class 10 level. So by heart now itself means not immediately. Daily, the textbook there is a table given. From that you first learn the names in the order. That is your first homework I am giving. Daily, if you can study more, 10 plus 10 you study, or you study 5 per day, like that 4 days you can finish, or you study 2 per day also, but every day add to the previous one, keep on revising for at least next 3-4 days you revise, you will be thorough with the first 20. So if you know the 20 elements in order, rest of the things will fall in place, because from this itself you can learn a lot of other concepts. Clear? So this is how electrons are distributed. Now we are going to understand two very important concepts, valence electrons and valency. Valence electrons, nothing but the number of electrons present in the outermost orbit. We found that hydrogen had only one shell, 1. So valence electron is 1. Helium had 2. So valence electron is 2. Then lithium came, it had 3. But what is valence electron? Not 3. Outermost what is there? Only 1. So lithium 1. Then beryllium 2. Boron 3. Carbon 4. Nitrogen 5. So how it happens outermost? So neon, it had 2 in the K shell and then 8 were in the L shell. So 8 is the outermost number of electrons, that is valence. When it came to sodium, it had 2 in the K shell. L shell, how many were there? 8. And M shell, it was only 1. So what is valence electron? 1, not 11, but it is 1. Outermost, what is there? So hydrogen also had 1. Sodium also has 1. Understood? Then again potassium, when we wrote, potassium 19 is the number. So K shell had 2. L shell occupied 8. M shell also had 8. So how much is over? K, L, M is full. When it came to N shell, 1 came to N shell. So it also has valence electron 1. So hydrogen also 1, but that was in the first orbit. Sodium also has 1, but it is in the M shell. And potassium also has 1, but it is in the N shell. So like that, we have different elements having the same valence electron. Suppose outermost is 2, valence electron is 2. Outermost is 3, valence electron is 3. So only outermost number of electrons we are seeing. But every atom, how many can be there? Only 8 maximum can be there, except for K shell. K shell has 2. So in the previous chapter also we discussed something like a valency. That is, every atom has an ambition. What is it? To make the outermost shell 8. That is called the octet. Making octet is the dream of every atom. But except for a helium, because for helium outermost is a K. How much it can have? It can have only 2 maximum. So it is happy. 2 possible, all 2 are there, so it's happy. But 3 onwards, they will try to make it 8. 8 is their target. So if they get 8 electrons, they are so happy because they are full. They are energetically stable. They don't have to go for reactions, right? So those elements which are having atoms with the 8 in the outermost orbit, they are not reacting. Whereas rest all, whether it is 7 or 6 or 5 or 4 or 3 or 2 or 1, they will be frantically running around to make it 8. So that will make them react with the others. Suppose if there is only 1, for example, sodium has only 1. But sodium also has the ambition of making it 8. But you know that taking 7 is needed for making it 8. But taking 7 from somebody is very difficult because 7 is a huge number. Who will give 7? So instead what can it do? It can give that 1 to someone so that now outermost is L, it is full. The same way potassium, it also has 1. Getting 7 is difficult. It will prefer giving 1. So now the outermost is M, it has 8, happy. So by giving they are satisfying their need, that octet. Whereas in some cases like chlorine is 17. So 2 in the K shell, 8 in the L shell, 7 in the M shell. So for chlorine only 1 is required. So chlorine cannot give 7 for that sake. So chlorine will be looking for 1. If it needs sodium, well and good. Sodium will tell, okay, you take, I have only 1, you take, I will be happy. Then chlorine will take that, so chlorine will become 8 in the outermost shell. So this is how they are engaging in reactions. They will either give, if it is 1, 2 or 3, they will give. Get rid of it. 1, okay, take it, I don't want. 2, okay, you take it. 3, take it. Okay. So these, by giving, these are metals actually. These metals usually have the tendency to give. Whereas if it is 5. Taking 3 or giving 5 is easy. Taking 3 is easy. If there are 6 in the outermost, giving 6 or taking 2 is easy. Taking 2 from somebody is easy. Or if it is 7, giving all 7 or taking 1 is easy. Taking 1 is easy. So these are the non-metals they usually receive from others. So if outermost is 5, 6 or 7, they will be taking 3, 2 or 1 respectively to make it octet. They are non-metals, so they receive. But metals give. Now there is in between case. If it is 4 between these two, giving also 4, taking also 4, doesn't make much difference. So what they do? They share. Share with someone else. Either with someone who needs 4 or with someone who needs 1. Means 4 people will come, right? Or 2 can be joined. Like that they can share also. So all the atoms will try to make the outermost octet complete so that they will not become reactive or they become stable. For that, they either gain electrons if they have outermost 5, 6 or 7, or they lose electrons if they have valence electrons 1, 2 or 3, or if it is 4, they have a tendency to the share. And another thing here you can see, metal and non-metal can, because these metals are ready to give, non-metals are ready to receive. This can give here, this can give here, this can give here. So give and take relationship, they can form compounds by giving and taking share electrons. That way also reactions are happening. So valence electron is the outermost shell. How many electrons are there? Valence electrons. And the combining capacity, what we discussed, is the valency. So valency is only the how much is given or taken, not the outermost. Suppose outermost is 7, they will take 1. So valency is 1. But valence electron is 7. Outermost is 6, it will take 2. So valence electron is 6, valency is only 2. 5, outermost is 5, so valence electrons are 5, but valency is only 3. Here, valence electron 1, valency is also 1 because it's giving that 1. Valence electrons 2, valency is also 2. Valence electron is 3, valency is also 3. So valence electron can be 1, 2, 3, 4, 5, 6, 7, 8. But valency can be 1, 2, 3, 4, 0 only. Because if there is nothing to give or nothing to take, we can call it as 0. Now let's learn about atomic number. We know that different atoms have different number of electrons and different number of protons. So the protons are actually present in the atom. The number of protons is called the atomic number. So usually in the neutral atom, number of protons and number of electrons are actually equal. So we can say that number of electrons also represents atomic number, but when the atom is losing or gaining, as we mentioned before, the electrons will change. But protons never enter into any reaction, so protons are intact inside the atom, so that is considered as the atomic number. So atomic number of an element is represented as Z. So Z represents atomic number. For example, hydrogen. Hydrogen has atomic number 1. Sodium has 11. Calcium has 20. It depends on the number of electrons. So far we saw a few examples. Their electrons were also the same. Now coming to next point, mass number. The name itself, mass, right? So what is mass? The atomic mass we already learned, the mass of an atom, right? So here mass of an atom is concentrated in the center of the nucleus of the atom. So the nucleus consists of protons and neutrons. Positively charged protons and chargeless neutrons are in the center. Electrons are revolving around the orbit. So mass of the nucleus, what will that be? The proton and neutron's mass, right? We already learned in the beginning that proton has 1 unit, neutron also 1 unit. Electrons are negligible, so we don't calculate. So number of protons 10 means 10U is the atomic mass, right? No, not 10U. 10U is the mass of proton. Then another 10 neutrons there means what? 20. Then 20 will be the mass of that atom. So mass of the atom is the mass number, and that is the sum of the mass of protons and neutrons. We can say not mass, number also, because each one is 1U. So number of protons plus number of neutrons together we will get what? The mass number. Then coming to isotopes. Isotopes means the same, every element has its atomic number. It's like their roll number. For example, in your class, roll number 13 is you or roll number 17 is your number. It won't change. Only one person will be allocated one number, right? The same way atomic number also, only one atom or element can possess that atomic number. So always hydrogen is 1. 20 means calcium. 19 means potassium. No change. But so their number of protons are equal. Their number of electrons are also equal, but they may have different mass number because the neutrons may be more than the number of protons. So in that case, mass number will be little higher. For example, hydrogen. Hydrogen you have to remember, keep in mind till you learn chemistry, as long as you learn chemistry, this should be in your mind, that is hydrogen is not having a neutron. In the nucleus of hydrogen there is only one proton, so one unit, and one electron is revolving around. So its atomic number is also 1, mass number is also 1 unit only. But for rest all, mass number will add the number of neutrons also, so atomic number and mass number are different. Understood? So here hydrogen can exist in 3 forms. All of them will have the same atomic number, that won't change, that is 1, number of protons. But there can be hydrogen with a mass number 1, that means no neutron. But there can be with the 2, means the 1 neutron is there, or there can be with the mass number 3 also. So mass number 1, this is called a protium. Second is called a deuterium. Third is called a tritium. So the same hydrogen can exist in 3 different forms or with the 3 different mass numbers. Those are the isotopes of hydrogen. The same way when it comes to carbon. Carbon can have 6 protons only. So 6 protons means 6 is the atomic number, that won't change. But some carbon can have mass number 12, means neutrons also 6. So 6 plus 6, 12. But some variants are there where the mass number is 14. So these two are isotopes of carbon. This is a heavy isotope. The same way chlorine. Chlorine atomic number is 17, means number of protons is 17, and in a neutral atom number of electrons also 17. But their mass number varies. It can be either 35 or 37. So when we calculate the atomic mass of certain elements, there can be fractions. For example, if you take the atomic number of copper. Copper it is 63.5, or chlorine if you say it is 35.5. We know chlorine can exist as 35, that is 75% of chlorine exists as a 35 mass number, and 25% will be existing with a mass of 37. So when we take chlorine altogether, it may have both, right? With the ratio 3:1, 75% and 25%. So when we calculate the mass number, we take the average of these two. So 75% of 35, that means 35 into 75 by 100 plus 37 into 25 by 100. So here 3 by 4, here 1 by 4, right? So when you calculate, the total will be 35.5 units. So this is how we are getting the mass, atomic mass as a fractional points or decimal points. Now the next concept is isobars. Isobar is opposite to this. Isotope means same atomic number, different mass numbers. Where in isobars, same mass number but different atomic number. Different atomic number means what? Different elements, right? So here argon is an element with atomic number 18. Calcium is an element with atomic number 20. So they have 18 protons and 20 protons respectively. But they both have the same mass number. So mass number is same, atomic number is different, but they are different elements. But isotopes are the same element only. Understood? The same way sodium, radioactive sodium has a mass of 24 mass number. Magnesium, normal magnesium has also 24. So they are also isobars. So that's the concept of isobars. So these are the main things you should remember. In an atom, the central part is nucleus. Nucleus consists of positively charged protons and chargeless neutrons, and around that in specific orbits like K, L, M, N, who is rotating, the electrons are rotating, and each electron has a negative charge, and each shell can hold 2 into n square number of electrons in it. but the outermost always should have 8. The number of electrons in the outermost shell is called a valence electron. So to make the outermost valence electron 8, the atoms may lose electrons like 1, 2 or 3, or gain electrons again 1, 2 or 3, or share sometimes. This combining capacity of atoms is called the valency of that atom. If it is 8, they are completing their octet and they don't go for reaction, they are unreactive. Those gases, those elements are otherwise called noble gases. They are all gaseous forms and they don't react. Now we learn atomic number. Number of protons is called the atomic number. Number of protons and number of neutrons in the atomic nucleus together called the mass number, because both have 1 unit mass. Electron does not have mass, so we don't calculate. Same atom with the same atomic number, but their mass numbers are different, then it is called a isotope. Different elements with a different atomic number, but their mass numbers are same, they are called a isobars. When we take the average of the mass numbers with the existing percentage, we get the atomic mass of that particular atom in decimal forms. So as I told, these are the important things to remember. Go back to the table in the textbook. You make a table of your own. Write the first number 1 to 20. Learn the names. Then you can write the rest of the columns. That is number of electrons, number of protons. That will be equal to the serial order, that number only. Then number of neutrons. No need to write, that is not important. But atomic number will be number of proton. Mass number you can also find out. That you have to learn actually. It's not finding out, you have to learn. But that not required in your level. You have to learn basically valence electron and a valency of each one. Valence electron increases from 1 to 8, whereas valency will increase from 1 to 4, then 0. Now coming to there is something called electronic configuration. When we are writing K shell how many, L shell how many, M shell how many, N shell, that is called electronic configuration. For example, sodium I told K2, L8, M1. So 281 is the electronic configuration of sodium. So the last what is coming, that is the valence electron. If it is 1, 2, 3, that is the valency. If it is 5, 6, 6, 5, 6, 7, 3, 2, 1 will be the valency. Don't get confused, okay? Keep practicing. Learn this very thoroughly. Anytime anybody asks, you should be in a position to explain to them. That is the level of learning you need in this particular concept. So if you understood, please do me a favor, share with your friends. Please help me to make my videos reach to maximum people. Thank you so much for watching Biology My Passion.